discussing about the polyvinyl chloride and polycarbonate, that is also the one of the very important thermoplastics, and other one of the important class of the polymer, that is thermoset resin. So, in that we will be discussing about the phenol formaldehyde, uriaformaldehyde, melamine formaldehyde, and also epoxy resin. The coverage of the lecture, that will be introduction, we will be discussing in detail about the polyvinyl chloride. So, the polyvinyl chloride PVC manufactured in India, polyvinyl chloride end uses, polyvinyl chloride historical review, sector wise use of polyvinyl chloride, what are the monomer for polyvinyl chloride, PVC process, and hazards of the polyvinyl chloride. This is one of the important issue in case of the manufacture of the PVC, and at the same time not only the hazard, also because it is requiring huge amount of the chlorine, and so the transportation of the chlorine and then the other products hydrogen and sodium hydroxide, that is also creating some issues regarding the probability of the this PVC plant. And hazards, so for the hazard is concerned, because we are handling the chlorine, we are handling the when the explosion that is reported in the vinyl chloride reactor also. So, these are the from the environmental point of view also, the PVC, there is some of the major issues are there. We will be discussing about the polycarbonate, its uses and manufacture, thermoset resins, and then in this class the formaldehyde resins are very important. In formaldehyde resin we will be discussing about the phenol formaldehyde, uriaformaldehyde, melamine formaldehyde, and then melamine epoxy resin. Polyvinyl chloride is one of the most widely used thermoplastic with diverse application in construction, wire and cables, pipe and fittings, film, packaging. Despite pressure from the environmental concern, which I told you, there has been constant growth in the demand of PVC, and the demand is increasing. Polycarbonate, another important thermoplastic, is the one of the fastest growing engineering plastic and is finding wide application in electrical and electronic industry and in optical grade of the optical glasses that we are making from this. The phenol formaldehyde, urea formaldehyde, melamine formaldehyde, the important thermoset resin, and phenol formaldehyde, as you know the name, it started the backlight and with the commercial name backlight, and the earlier all the electrical switches and other materials, phone, they were all made of the phenol formaldehyde, although that as the other resins are also now we are using. Let us now discuss in detail about the polyvinyl chloride, then we will discuss about the thermoset resins. Polyvinyl chloride is second largest after polyethylene and most versatile of all the thermoplastic. It contains about 56.8% of the chlorine and balance being the hydrocarbon. So, the chlorine, that is one of the very important raw material for the PVC, and you see the what happened in case of the Middle East. There when the PVC manufacture was started, they started the caustic chlorine plant, and there was less use of the caustic and hydrogen than the chlorine, and so this is the reason why they call it the chlor caustic and not the caustic chlorine industry. So, that is one of the issue in case of the polyvinyl chloride, because the manufacturing point will be at one place and your user will be at another place. Only some of the petrochemical complex like Reliance, they are having their own caustic chlorine plant at Gandhar. So, PVC has outstanding combination of durability, stability, flame retardancy, heat electrical insulation properties, recyclability, excellent long term weather ability and lower price because of the coming of the, you see there has been the one of the major driver for the PVC production, that has been the availability of the ethylene from the naphtha cracker, because earlier it was the ethylene from the molasses route, or it was from the calcium carbide route, acetylene and acetylene to then your vinyl chloride. So, this was the actually one of the major issue in case of the polyvinyl chloride. With the addition of plasticizers, fillers, reinforcement, lubricants and stabilizer, PVC may be formulated into flexible, rigid, elastomer or the foam compound. Global production and consumption of the polyvinyl chloride in 2010 was approximately 34 million metric tons. So, for the vinyl industry in India is concerned, vinyl industry in India is valued about 20,000 crore. India's imports are slated to increase to 19% by 2016. Construction sector is major consumer of the PVC, because you see now the pipings, pipe fittings and the insulating material for wire, this all the PVC flooring. So, the one of the major consumer is the construction sector. Indian PVC market is characterized by the dominant pipe market, which I told you, the pipe and pipe fittings. The major end use application of the PVC can be broadly classified in two groups: rigid PVC application and flexible PVC application. Rigid PVC find application in the pipe fittings, conduits, films, bottles, etc. Flexible PVC finds application in wire, cable insulation, seats, hose tubes, footwear and other uses. Building, construction, agriculture sector, as I told you, are the major consumer of the polyvinyl chloride. This is about the sector wise consumption of the, you see the one of the major consumer is the pipes and fitting, calendering, films and seat, wire cable, footwear, prop, and then your bottles, others. So, this is the in all the total, even worldwide, the percentage of in pipes and fitting, that is around in India 68 and in the other part of the world, that is the 37%. PVC and capacity and demand in 2011-12 was about 1.3 and 2.08 lakh tons respectively. Demand of PVC by 2016 and 17 in India is expected to be 3.1 lakhs ton per annum. So, you can just imagine the requirement of the PVC, the figure which we are having in 2011 and 12 and the figure which is expected projected in 2070. So, definitely we need more PVC plant. Per capita consumption of the PVC in India was 1.2, that is the 2006 figure against the world average of 5.1. PVC in India 2009, this is the installed capacity and the production, that is 1,279,000, that is the installed capacity and production is 110. PVC production. Now, let us some historical review of the polyvinyl manufacture in India, because the early stage before coming of the this petrochemical complexes or the naphtha cracker, PVC was manufactured. So, PVC production in India was started in the year 1961 by Calico, and you see the after that the cracker plant came, that is the Union Carbide cracker plant or the Nocel or the IPCL, now Reliance in Vadodara, they were all during the 65, 66 and 70, which so the PVC production in Calico, that was based on the acetylene produced from the calcium carbide. This is the route. Still, even the Serum chemicals and fertilizer they are making by this route. First alcohol based PVC plant was started by Chemplast in 1967. This was the first alcohol based plant, because the alcohol to ethylene and ethylene to vinyl chloride, that was the EDC and EDC to vinyl chloride, that was the process, because even at that time 1966 ethylene was not available from the petrochemical complexes. Siram Chemicals and Fertilizer at Kota, Rajasthan is another unit which is based on the PVC by calcium carbide. They are using making the calcium carbide and calcium carbide to acetylene, and from the acetylene to vinyl chloride. First integrated PVC plant based on the petrochemical route using ethylene from cracker plant was commissioned in 1968 by Nosel, which is now closed. It has been taken over by Reliance, and it is now the your corporate office of the Reliance is at this place. Reliance Industry brought a sea change in the production of the polyvinyl chloride with a world scale plant at Hazira and later at the Gandhar in Gujarat, because these are the two major complexes which are making huge amount of the polyvinyl chloride, and Gandhar unit of the Reliance, which was earlier by the IPCL, they are also having the caustic chlorine plant. So, the requirement of the chlorine, that is from their own generation, own production of the chlorine. These are the various units: Reliance, earlier IPCL, Phenolex, Hazira. This is the location of the plant. This is the startup of the various plants in India, and this is the. So here, if you see the your sources of the feedstock, naphtha cracker, Phenolex vinyl chloride from ethylene, and then the chemiplast ethylene from alcohol, Mature Tamil Nadu. This is the starting year 1967. The CW Tutikon, that is the acetylene from calcium carbide route, DCM Siram Kota Rajasthan. They are again using the acetylene from calcium carbide route for vinyl chloride. These are the some of the broad application. You can see the of the fittings, pipe fitting. Even it has been reported they, along with the polypropylene PVC, is also using a appreciable amount of the PVC that is being in the hospital material, that is for the packaging in the hospital, that is even the syringes and other materials. So these are the some of the pipe fittings, these are the some of the other material that we are making, then the vinyl flooring that you know, and this is the water tank made of the PVC. So this is the how the PVC that is playing very important role in providing many of the items which we are finding used in the even the tires. There was a issue of the PVC tires which was supplied in African country, and that was having some carcinogenic material, and so that was the issue there. So that is one of the environmental issue regarding the PVC use, but in the tires also the PVC that we are using. So basic monomer for manufacture of polyvinyl chloride is the vinyl chloride, which is made from either, as I told you earlier also while discussing the raw material for the chemical industry, and time to time in the even the during the petrochemical, the various routes for vinyl chlorides, that is the earlier route. It was the acetylene followed by the ethylene from the ethanol, and then after coming of the cracker plant at Nosel or the IPCL Vadodara, and the later by the IPCL another unit Gandhar and the Reliance Hazira. These all started making the vinyl chloride through the your naphtha route. So this is the sources of ethylene, naphtha, gas cracking, alcohol, and now the another actually the interest is there from the FCC gases, because while discussing the FCC gases, recovery of C4, C5, I told you that the FCC gases also contain the lean stream, low percentage of ethylene in the gases, and so that recovery now the refineries they are just looking for the recovery of the ethylene also from the FCC gases. Sources of acetylene, that is the one route is the calcium carbide, where we do not need any hydrocarbon, that is not dependent upon the petroleum industry. Another route for the acetylene, that may be methane, which is also one of the source of the methane, and already we discussed and these two methods, how we are acetylene, what are the reaction involved in the acetylene from the calcium carbide or the methane route. This is the PVC plant of Sriram Chemicals and Fertilizers Kota, and this is the courtesy Sriram Chemicals and Fertilizers Kota. This figure is the PVC plant they are having, that is based on the acetylene from the calcium carbide, and this is the calcium carbide plant. So, you can see the environmental condition also in that plant. So, this is the route how we are making the calcium carbide. These are the some of the location, already we discussed about the location, but what are the routes they are making for the whether acetylene, that DSCl, that is the calcium carbide, to acetylene, to the vinyl chloride monomer, chem plus molasses, to alcohol to ethylene, and then the ethylene dichloride, what is after cracking vinyl chloride monomer and the PVC that we are getting. The DCW VCM to PVC, Reliance Badodra, Reliance Gandhar, Reliance Hajra. These are all using the ethylene from the cracker plant, and the Phenolex Ratnagiri, they are also using the ethylene for making of the vinyl chloride. So, what are the process technology that is available? Although the suspension polymerization is very common, but using a free radical initiator PVC can be made with any of the four general methods of the polymerization: suspension, emulsion, bulk, and the solution polymerization. However, bulk of the PVC is made by the suspension polymerization. So, but all the four methods that can be used, but most of the PVC is made by the suspension polymerization. So, most resin produced by the suspension polymerization are in the range of 125 to 165 microns in diameter, while those produced by bulk polymerization are in the range of 1 micron diameter. So, this is one of the comparison of the bulk polymerization and the suspension polymerization for the manufacture of PVC. Now, let us discuss about the process technology for polyvinyl chloride. Suspension polymerization of the PVC has significant advantage such as low investment, large reactor technology, clean reactor wall technology, low personal requirement, and environmentally safe. So, these are the some of the advantage of the suspension technology. With the vinylidene chloride, because that has been, even in case of synthetic fiber also, vinylidene chloride that has been added in case of the acrylic fiber. So, the PVC has a higher melting point than the homopolymer and may be spun into a fiber also. So, this is the PVC by suspension Cheso Corporation, that the process licensor, and Phenol process by both the process are based on the suspension polymerization. Let us now discuss the various steps involved in case of the suspension polymerization process of the polyvinyl chloride manufacture. Suspension polymerization of the polyvinyl chloride manufacture involves dispersion of the vinyl chloride monomer in water, as name itself see that the suspension, the monomers are in the suspension form. So, the chloride monomer is in the vinyl chloride monomer is in water along with a suspending agent is there, and so the polymerization is initiated by activators at temperature and 40 to 70 degrees centigrade. Heat produces continuously removed using heat transfer media. After the polymerization is completed, the suspension is transferred to the degassing unit where unreacted monomer is removed, purified, condensed and recycled. Polymer from the suspension is separated by centrifuging and then it is further dried by hot air. This is the process for the manufacture of polyvinyl chloride. Here you see the this is the material, the vinyl chloride monomer along with the catalyst, and then the water that is going to the your autoclave to the flash tank where we are recovering the vinyl chloride monomer, and which is again it is recycled, and from the steeper also it is from flash tank, then from steeper also the vinyl chloride monomer that will be recovered and that will go to the autoclave, and then the bottom of this column that will be the PVC that will go to the for the centrifugation and the separation of the PVC, and it will go to the dryer to again the cyclone to separator, and then the 16 and finally the storage. So, this is a brief about the PVC manufacturing technology. As I told you earlier, because there are always some hazards associated with the polyvinyl chloride, and one of the reason is because we are using, as I told, the large amount of the chlorine is there in the polyvinyl chloride, and the handling of the chlorine, then the plant, they are not at the site of the unit. So, transportation, that is one part, that is regarding the economic part, but in case hazards is concerned, that is because of the your chlorine. The manufacture, use and disposal of the PVC substantial and unique environmental, even the disposal of the PVC, because even if you are going for destruction, distillation, the chlorine vapor that will come. So, this PVC poses substantial and unique environmental and human health hazard which has been recognized all over the world. PVC is the largest consumer of chlorine and consumes about 40% of the total chlorine production. So, this is the, you can just see the amount of the chlorine that is being used, but you see the here one of the major changes that is, because always the manufacture of the caustic chlorine that was considered also the hazardous because of the use of the mercury cell process, but after the coming of the membrane cell process for the manufacture of caustic chlorine, that is some of the hazards associated with the caustic chlorine plant that has been minimized, but still that chlorine which is in the PVC, that is create problem. Another problem is in the reactor, vinyl chloride reactor also, some of the explosion that has been reported in the vinyl chloride reactor also. Very large quantity of hazardous organic chlorine byproducts are formed and released to the environment at numerous points in the vinyl life cycle, which are highly persistent, bioaccumulative and toxic. Severe contamination of the communities and water system in the vicinity of the vinyl chloride monomer production facility has been reported. So, this is why I was telling the vinyl chloride, it is not as such the PVC, it is the vinyl chloride monomer plant, that is one of the major source of the pollution. So, VC monomer induces the aneurysm, coma and a liver cancer. So, this vinyl chloride, because that is present in the, because we are doing the polymerization VCM. So, that is one of the problem in the utilization of the PVC, and that problem which I told you earlier, and that was in the toys, the hazards of the toys when the children are using it. So, that has been there, that has been reported in the literature. Now, let us discuss another important class of the thermoplastic, that is the polycarbonates. Polycarbonates are the thermoplastic and are the one of the fastest growing engineering plastic. Global demand of the polycarbonates exceeds 1.5 million tons. So, here again the problem, some problem regarding the environment is there, because in the manufacture of bisphenol and the manufacture of polycarbonate, bisphenol we need the phenol, in case of the polycarbonate we need the bisphenol and the phosgene. So, the hazardous nature in case of the phosgene, preparation of the phosgene. So, that is one of the issue in case of the manufacture of the polycarbonate. So, for the polycarbonate, why the polycarbonate has gained so much importance, because you see the earlier it was the polycarbonate technology that was not well developed regarding especially the bisphenol manufacture and the your phosgene manufacture, but at the same time some of the excellent properties of the polycarbonates are there, which are the major driving force for the development of the polycarbonate industry. So, the polycarbonate are transparent and are break resistance. Polycarbonates are thermoplastic used in the several applications and have exceptional optical clarity, and this is the reason why we are using in the optical glasses. Impact strength, flame resistance, low wrap pace, excellent electrical properties and dimensional stability, high heat distortion, temperature, lightness, durability. So, these are the some of the important properties of the polycarbonate, which has led to the more and more use of the polycarbonate. Demand of the polycarbonate is growing fast and find application. One of the area which I told you, the lighting lenses, sunglass, eyeglass lens, safety glass, CDs. This is the one of the major revolution in case of the CDs and DVD, which is the raw material we are using the polycarbonate polymer. Automotive headlamp lens, lab equipment and drinking bottles also. Even in case of the because this is having high strength, in the shoe also, in the some of the sports material also we are using the polycarbonate. So, for the process technology is concerned, polycarbonate is produced by condensation polymerization of sodium salt of bisphenol and phosgene in the presence of organic solvent. The sodium chloride formed during the process is precipitated and the solvent is recovered by distillation or evaporation. This is the reaction that is taking place, and as I told you that we are having the two important feedstock, that the bisphenol and phosgene. Again in case of the bisphenol, because the raw material is the phenol, and so the from phenol then the phosgene, and then after the polymerization we are getting the polycarbonate. So, this is the process of manufacture and the reaction that is taking place in the manufacture of the. This is the in brief about the block diagram of the polycarbonate process, that is the bisphenol, NaOH and the phosgene, that is going to the the reactor, polymerization reactor, where we are using the solvent methylene chloride, and then it is going to separator, aqueous layer that is separated, and the organic layer, that is the caustic was and the water was and clear solution, solvent vaporization, and then the precipitation, spray drying and extraction and the pelleting, that is the final polycarbonate that we are getting. Now, let us discuss some of the important thermoset resins. This was the polycarbonate and the PVC, about the important class with thermo. So, for the thermoset resins are the we are having a three major group of the thermoplastic, which we are finding application. The thermoset resins are characterized by a high degree of cross linking, resistance, deformation and solution once their morphology is achieved, and are usually prepared in molds and that yield the desired shape. These polymers once formed cannot be reshaped by heat as in case of the thermoplastic. This is the basic difference between the thermoplastic and thermoset resins. Some of the important thermoset resins are the phenolformaldehyde, uriaformaldehyde, melamine formaldehyde, epoxy resin and polyurethane. They are also coming in the category of the thermoset resins. Formaldehyde resins, because we discussed about the three important resins which are the phenolformaldehyde, uriaformaldehyde and melamine. So, formaldehyde resins are important thermoset resins. A large tonnage of the formaldehyde is used, and this is one of the we discuss. I told you that by discussing the formaldehyde, because methanol, this is the reason why this importance of the methanol from the petrochemical point of view for intermediate, apart from the fuel and the fuel cell, these are the methanol to olefin technology. One of the major consumer is the formaldehyde manufacture, and this formaldehyde, that is we are using in manufacture of the resin. So, the formaldehyde resins are of the two major groups, the phenolic resins, where we are having the phenolformaldehyde, amino resins means the uriaformaldehyde and melamine formaldehyde, and thioureaformaldehyde is also there. So, this is coming in case of the amino resin group. Both phenolic and the formaldehyde resins offer a strong bond and good resistance to high temperature. This is the one of the advantage. The major application of the formaldehyde resins include binder in plywood. You see the phenolic resin, that you see you must have even sometimes if you go to any plywood industry, you will find the smell of the phenolic resin. So, that is one of the major consumer is the binder which you are using in case of the manufacture plywood manufacture. In lacquers, varnishes, molding compounds, electrical switches. As I told you, this was in the name when it was manufactured, the name of the backlight was there, and so the earlier you must be remembering that now there has been a lot of the changes in the switch configuration, but earlier it was all the backlight that was going to the electrical. Even the color almost it was the black that was being used, but now the more fancy insulation your electrical appliances are there. So, the change in the use pattern is also there. Decorative plastic, dinnerwares that we are using in the case of the melamine formaldehyde. So, these are the raw material for the formaldehyde resin, phenol, urea, and this is the importance why the first generation chemical in any petrochemical book you see it will be the first hydrogen, ammonia and urea, because the ammonia and urea they are not only important from the petrochemical point from the fertilizer point of view, but also from the petrochemical point. Even in case of the melamine, which is the again for we are using for melamine formaldehyde, that is also product of some of the fertilizer plant, and one of the plant that which are making the melamine, that is the your Gujarat state fertilizer complex. So, these are the some of the major raw material which I told you, phenol, urea, formaldehyde and the melamine from the urea that we are making in the fertilizer plants normally. So, let us discuss now about the phenolformaldehyde resin. Phenolformaldehyde resin, a product of the condensation polymerization of phenols and formaldehyde, is the oldest condensation reaction, and the product is the most important of the thermoset resin. So, I told you that the phenolformaldehyde resin in the name of the backlight, so that was commercialized in 1909 and is made by either base catalyzed addition of the formaldehyde to phenol, that is Rishol formation, single stage process, or by acid catalyzed Novolog formation, two stage process. So, this is the two types of the phenol formaldehyde resin. Phenol formaldehyde resin, depending upon the ratio of the reactants, formaldehyde and phenol molar ratio and the catalyst type, acidic or basic polymer with different property that we can found. So, these are the some of the actually important parameters which can be adjusted to make the different property of the phenol formaldehyde. Two types of the products are produced during the reaction of the phenol and formaldehyde, which I told you, the novolic and the resol. Phenol formaldehyde and resol phenol formaldehyde novolic resins are acid catalyzed polymer, while resol are base catalyzed polymers. In no-log process, molten phenol and formaldehyde is polymerized in presence of the acid catalyst. Formal to phenol molar ratio of 0.75 to 1 to 0.85 is maintained. The polymerization is completed in 6 to 8 hours at 95 degrees centigrade. The volatiles and the phenol are recovered and the polymer is recovered and converted to desired form. Now, let us discuss about the urea and the melamine formaldehyde. So, urea formaldehyde resin is a non-transparent resin and find application in adhesives, molded objects, decorative laminates, textile, paper, fonde and the molds. Because of its high reactivity and good performance, it is widely used as an adhesive for particle board and hardwood plywood. Urea formaldehyde is made by condensation reaction of urea and the formaldehyde. This is the reaction that is taking place in case of the phenol formaldehyde, and this is from the urea formaldehyde, not the melamine but urea formaldehyde. This is the actually you see the I was telling the earlier the now you are having the different types of the, but this was the original phone. If you see that is the made of the backlight, means the phenol formaldehyde resin. Now let us come to the melamine formaldehyde, because that is the one of the very important resin and that came into the market and replaced most of the stainless steel normally we used to have in our kitchen. That was because of the cheap, cost was less and at the same time lightweight, and durability, that was not a problem. It was so by it is not breakable as in case of the your glasses and other kitchenware material that were used. So, melamine is produced from the urea, which I told you, the and when the molten urea is heated to about 360 to 372 in presence of the quartz, and urea decomposes to isocyanic acid and ammonia. Further, isocyanic acid is converted to melamine in the presence of alumina catalyst. Carbon dioxide produced as byproduct. So, this is the actually the melamine structure and process involved in case of the melamine formaldehyde resin. First thing is the melamine synthesis, which is the urea decomposition, melamine scrubbing, filtration and drying of gas stream and ammonia recovery, ammonium carbonate liquor treatment, mother liquor treatment and the ammonia reliquefaction and batching. This is the about the not exactly the formaldehyde, but it is about the in case of the melamine manufacture, this is the method that we are using. So, the importance why the melamine formaldehyde, I told you earlier also with the coming of the melamine formaldehyde, that replaced almost the stainless steel in the kitchenwares and other your kitchenware material. So, the melamine formaldehyde resin is commonly used as a kitchenware. A melamine formaldehyde resin has low water absorption and better chemical and heat resistance than the urea resin. However, major application is as bonding and the adhesive components. This is the reaction that is taking place and the condensation of the urea. Melamine react with the urea to form melamine resin. Melamine reacts with the formaldehyde through a, this is for the melamine, for making of the urea to form melamine, and not resin but melamine is fine. And then melamine with the reaction the formaldehyde, that we are getting the resin. This is about I told you that how the melamine that is being made. Melamine is made from the urea. This is the reaction that is taking place while making of the melamine. Now let us discuss about the one of the another important thermoset resin, that is the epoxy resin. Epoxies are broad class of reactive monomers and resins containing epoxy functionality. Crude epoxies have good chemical and corrosion resistance, high, now you see the in case of the epoxy resin in the paint industry, huge amount of the epoxy resin that is being used. So, the high addition to a variety of substrate and low shrinkage during the there. So, epoxy resin are made by reaction between diphenol and epichlorohydrin. Here also the involvement of the chlorine while making the epichlorohydrin is there. So, most commonly used epoxy resin is made by reaction of bisphenol and the epichlorohydrin. So, again here the same problem, handling of the bisphenol manufacturers, where we are handling the phenol and the poison is there. So, for the why we are so importance of the epoxy resin. Epoxy resin find extensive application in coatings, adhesives and composite materials. Epoxy resin may be classified into various trade name that has been given: DGBA resin, DGBF resins, BCF resin, epoxy novolac, brominated epoxy resin, linear aliphatic resin, cycloaliphatic resin, cycloaliphatic and the multifunctional resin. Among the various epoxy resin, most widely epoxies are those derived from the phenol and the epichlorohydrin. Let us discuss in brief about the process technology, because as we know we need the two important feedstock, that is the bisphenol and the epichlorohydrin. So, here in the polymerization for making of the epoxy resin, epichlorohydrin is first fed to the polymerization reactor in large excess to facilitate the formation of DGB. Then bisphenol is added and dissolved, followed by addition of a strong caustic soda at controlled rate and with heating to start the reaction. As the reaction proceeds, a mixture of water and epichlorohydrin distills and is condensed. The water is removed from the separator and epichlorohydrin is refluxed back to maintain the excess molar ratio in the polymerization. After the completion of the reaction, the contents are drained out and the salt is removed by filtration. The filtrate is again charged to the reactor to recover the excess epichlorohydrin by vacuum distillation. Then the raw material requirement per ton of the epoxy resin is the bisphenol, epichlorohydrin, the caustic soda. So, this was about the some of the important thermoset resin and also the PVC resin, that the polyvinyl chloride, the importance of the polyvinyl chloride and the method process technology for the PVC we discuss. In the next lecture we will be discussing about the, because these two lectures were based on the polymer. The next lecture that will be on the elastomer, because the elastomers are also playing very important role and we are using in our daily life the various material from the elastomer. So, the next lecture of this module will be based on the elastomer, and there will be discussing about the natural rubber, synthetic rubber, historical development which has taken place, and some of the major synthetic rubbers which is being manufactured in India and other part of the world. Because you see the synthetic rubber industry with again the driving force for the development of synthetic rubber, that has been the coming of the cracker plant, but at the same time, and also the your um, petroleum refining. But at the same time, if you see the historical background which we will be discussing while discussing the SPR, that was through the non-petrochemical route, means it was ethylene from the your molasses.